Okay, welcome to Chapter 8, Section 4. We're going to be factoring polynomials that look like a times x squared plus b times x plus c. And unlike last section, in this section the a is not going to equal the hidden 1. So we're going to have some number multiplied in front of here. Okay? Now in the previous video, I showed you how we do this by what the book calls guess and check. And I mentioned that I'm not a big fan of that. I never liked teaching it. I never liked learning it. It seemed kind of stressful, and it kind of seemed like, seemed like a puzzle where you just keep trying things until it falls into place. Usually I try to lead my students toward a way of thinking about the choices that they make, so they do a little bit more in their head, but that's a little bit, that's a big step. So I'm going to show you a method that became popular a few years ago. Some people call it the diamond method because you draw a diamond. I don't really draw the diamond, but if you hear us refer to it as the diamond method, that's what we mean. And it's actually pretty slick. All right, and the best part about it is that it's based on doing stuff that you already learned in the previous sections. All right, so we're going to factor by saying what two numbers multiply to give this and add to give that. That'll be part of it. And also, we're going to be using that multiplication chart that we use a lot in Algebra 2, which helps us organize what we're doing. It just for me, and I said this before, as a visual person, I need to see a picture of everything. So, and I know a lot of students have said that they feel the same way. And you might be different. Everyone learns different, okay? So you do what's best for you. But let's get started. All right, the first thing we need to do is identify what the a, the b, and the c are. The a is multiplied by the x squared, the b is multiplied by the x, and the c is the constant that's being added. So basically, a, b, c. Excuse me, I'm charging my phone and I thought that it was off. Okay. Sorry for the interruption. I'm not going to restart the video. Okay? So my a is 2, my b is 11, and my c is 12. This is my a, this is my b, and this is my c. Now, what I'm going to do is I'm going to make a big X. Not like a variable X, but this is just to organize stuff. This top part is going to be a times c. So I'm going to say 2 times 12, which equals 24. This bottom is going to be the b. So I'm going to put the b here, and this is going to be a times c. And I'm not going to write b and a times c. Probably do it for that one, but then I'll stop doing that. Now, just like we did, what two numbers multiply to give 24, but they add to give 11? Well, I can go through my list of pairs of 24. 1, 24, that's going to be 25. Nope. 2 and 12, that's going to be 13. 3 and 8, that's it. So 3 times 8 equals 24, and 3 plus 8 equals 11. That's the first step, and it's related to what we did. It's the same thing as what we did before. But now here's the cool part. I'm going to take and I'm going to make my multiplication chart. Remember and I even did this with the guess and check video that maybe you saw before watching this one, from example 1. This part right here, the 2x squared, always goes in this corner, and the 12 always goes down here in this corner. And just for this problem, I'm going to draw all of the box. Usually I don't draw all the box. And I know that these two things multiply to give 2x squared, and these two things multiply to give 12. And then I got these two things add up to 11x. Well, what are these two things? There's lots of pairs that are going to add up to 11x. Well, I've already figured it out. Put 3x here and put 8x here. And if I put the 8x here and 3x here, it'll be fine. Just put these two in these two boxes with the x. So now this all, when I simplify it, is going to give me this, 2x squared plus 11x plus 12. Now all I have to do is factor like I did in 2 sections ago. What do these two have in common? They have a 2x. That leaves the other x, and that leaves a 4. What do these two have in common? They have a 3. 3 times x is 3x, and 3 times 12 equals, 3 times 4 equals 12. There you go, you got it factored. 2x plus 3 times x plus 4. Now, as always, you can pause that, rewind it, do what you need to if I'm not necessarily talking at your pace. Watch the next one, make a prediction about what I'm going to do. I'm going to start by drawing my big organizer, my big X. 5 times 8 is 40. And I put the negative 14 here. So remember, right here is A times C. And that's the A, that's the B, that's the C. This is just the B. So you take the first, multiply by the last, put it here, and you put the middle right here. What two numbers multiply, and the answer is 40, and the sum is negative 14? Well, the only way for that to happen is both of them are negative. So negative 1 times negative 40? No. Negative 2 times negative 20? No. Negative 4 times negative 10? Yes. So I get negative 4 and negative 10. All right. So now I fill in my box. I get 5x squared right here. That's that. The 8 goes in this lower right-hand corner. And I'll do it one more time, and then I'll stop doing it, because usually I don't. Right. These two boxes are going to be negative 4x and negative 10x. And one more time, it doesn't matter which one goes where. Negative 4x and negative 10x. Let's factor let's factor out a common factor from these two and put it right here. So they both have a 5 and they both have an x. That leaves the other x and negative 2. These two, that's 4 times 1 and that's 4 times 2. So they have a common factor of 4. Except 4 times negative 2 is negative 8. So if I factor out a negative 4, everything's going to match up. So 5x times x is 5x squared. 5x times negative 2 is negative 10x. And by the way, this is where I check my answer. The check is built into it. Negative 4 times x is negative 4x, and negative 4 times negative 2 is positive 8. So I get 5x subtract 4 times x subtract 2. And that's the factored form. All right. So my A is 6 and my C is 5. 6 times 5 equals 30. My B is 17. I'm going to put that right there. Everything is positive. Next time I'm going to have negative. Everything is positive, so everything is going to be positive. What two numbers multiply to give 30? Sorry, I was pointing the wrong thing. And when the product is 30, and when I add them, the sum is 17. So 1 times 30, 2 times 15, 3 times 10. It's the 2 and the 15. So make your multiplication chart. 6x squared, 2x, 15x, and 5. Remember, the first term 6x squared goes here, the last term 5 goes here. And these two come from here, what I just figured out, multiplied by the x's, because these two have to add up to 17x. All right, 6 is 2 times 3, and 2 is 2 times 1, so I have a common factor of 2 and an x. That means that the other factor here is 3x, and this one, that factor is 1. This one is 1 is what I started to say. These two have a common factor of 5, and I'm checking 5 times 3x is 15x, 5 times 1 is 5. So this is 2x plus 5 times 3x plus 1. I tend to fall into patterns sometimes. If you'll notice, go back to these other problems, I always write the one that goes down first and then the other one. So 2x plus 3 first and then x plus 4 next. 5x minus 4, x minus 2. I did the same thing here. It doesn't matter. Remember, 3 times 4 equals 12, and so does 4 times 3. It's called the commutative property. So if you write the 3x plus 1 first, then that's okay. And as a matter of fact, I'll purposely switch it up the next time to show you that it doesn't matter. The only thing I want to mention about that is that if we take an assessment on Schoology and it's a multiple choice assessment, just be aware that it can be turned around, okay, that there is commutativity there, right? So let's try this one. 9 times 4, let me draw my x, my big X. 9 times 4 is 36, and my b is negative 15. So what two numbers multiply to give positive 36, but when I add them, the sum is negative 15? The only way for that to happen is if both of them are negative. A negative times a negative is a positive, but when I add two negatives, I just get negative. All right? So I go through my list: negative 1 times negative 36, negative 2 times negative 18, negative 3 times negative 12. I think I got it. I could keep going: negative 4 times negative 9, negative 6 times negative 6, but I think I got it. This is negative 3 and negative 12. Negative 3 times negative 12 is positive 36, and negative 3 plus negative 12 is negative 15. So one more time, the 9x squared goes in this corner, the 4 goes down in the opposite corner. These two corners I figure out with this: negative 3x and negative 12x. And now it just goes back to what we learned a couple lessons ago. What do these two terms have in common? This is 3 times 3, this is 3 times 4. So they both have a 3, they also both have an x. That gives 3x here and negative 4 here, because 3x times 3x is 9x squared. This is me doing my check. 3x times negative 4 is negative 12x. Good so far. What do these two have in common? Doesn't look like they have anything in common. This is negative 1 times 3 times x, and this is 2 times 2. There's nothing here that's also here. So when they don't share any non-trivial factors, the common factor is going to be 1. But let's check it. Does 1 times 3x equal negative 3x? Does 1 times negative 4 equal 4? No, I ended up with this. 1 times 3 should be positive, 1 times negative 4 should be negative. What I have to do is put my negative here, and then it's going to work out. So now negative 1 times negative 4 equals positive 4. Negative 1 times positive 3 equals negative 3x. Okay, now, like I said, usually I write this first and that. That's just me being a creature of habit. So I'll write 3x subtract 4 times 3x subtract 1, just to show you that it doesn't matter. All right, we'll see you in the next video.